This is Algebra 1 Spring Test number 5 study guide. Number 1 is solve the following systems of equation, or the system of equations, by graphing. Remember, this is what we learned earlier in the week. We moved on to substitution after, which is a much more reliable method, but we need to understand this method first. The first step is to get these equations into forms that you are more comfortable graphing. Okay, you can use x and y intercepts for this, or you can put them into slope-intercept form, which most of us probably do. This first equation, negative 4x plus 3y is equal to negative 12. You want to make it say mx, y equals mx plus b by moving the x variable to the other side. That's first step, undo the minus 4x. That leaves you with 3y equals 4x positive, because when you add 4x to both sides, it becomes positive on the right. Negative 12 is already on the right. Divide by 3 on both sides, and you get y equals 4 over 3x, and negative 12 divided by 3 is negative 4. Now this says mx plus b. So this is in an equation form that we are comfortable graphing. On our y-axis, we begin at 4. Our slope tells us to go up 4 and to the right 3. So up 4 and over 3. There's our second point. The other equation, if we want to put it into a form that we're comfortable graphing, it says negative 2x plus 3y equals negative 18. Move negative 2x over by adding it to both sides. 3y equals, when it moves over, it becomes positive 2x. Negative 18 is already there. Divide by 3 on both sides. Y equals 2/3 x. Negative 18 divided by 3 is negative 6. Again, mx plus b, a form that we're comfortable graphing. Begin at negative 6. Go up 2 and to the right 3. So up 1, 2, and to the right 1, 2, 3. There's our second point. So we have to determine where these two lines are going to cross. It looks like these two lines are going to cross somewheres in this area. So we need to draw two straight lines to get to those, to that intersection, so we can estimate what it is. The first one is going to be this way. The second one is going to be this way. Actually, looks like we might have to move that line, this red one, a little bit. And this is the part, this is why I said it's not as reliable as doing it algebraically. We can move that one to there to see. Looks like it might be closer. We need to estimate what that intersection is. This intersection right here, we could estimate as negative 4, its x value, and negative 8, its y value. So remember, this is called the graph and check method, because you graph it, you estimate what it is, and then you check to see if negative 4 and negative 8 give you a true statement. So in the first equation, again, the red one, this one, negative 4 times x is negative 4 times x is negative 4. We know that gives us positive 16. Plus 3 times negative 8 is y. 3 times negative 8 is going to be minus 24. Equals negative 12. Okay, so this is not the correct intersection. Negative 4, because 16 minus 24 is not equal to negative 12. So somewhere along the line, with the straightness of my lines, probably, I made a mistake. And this is why it's not the most reliable method. So let's look back and get a different point. We probably have to just shift one of them over just slightly. You try to be as straight as you can. You try to make the intersection as clean and as neat as you can, but there's still some play to be had in it. And that's the problem with the graph and check method. So this looks like it might be a better intersection right here. Negative 3, negative 8. Let's see if that one works for it. Negative 3, negative 8. Again, we're going to move on to, in just a second, the substitution method. There's no guessing with the substitution method. When you plug these values in, negative 4 times negative 3 is positive 12, plus 3 times 8, negative 8 is negative 24. 12 minus 24 is negative 12. That one is a true statement. The other one, the negative 2x plus 3y equals negative 18. Negative 2 times x is negative 2 times negative 3. We know that's positive 6. Plus 3 times y is negative 8. That's minus 24 equals negative 18. Again, that one is true as well. 6 minus 24 is equal to negative 18. So this is our solution, negative 3, negative 8. And again, I did not try to show the error, but that shows what's unreliable about the graph and check method. Number 2, 3, 4, and 5, you're solving using the substitution method. Okay, so you're going to do these algebraically. You won't have to guess with these. Easiest way to do substitution is to write them side by side. Y equals 2x plus 3 and y equals 3x plus 1. Now with these examples, you don't have to decide which variable to isolate like yesterday. And you don't have to isolate anything because y is already isolated. Y is already on the left side of the equal sign by itself. Y is equal to 2 times x plus 3. So what you could do is you could take that expression and drop it in place of y of the other equation. That gives you 2x plus 3, again in place of y, equals 3x plus 1. So now what you have is variables on both sides. Move your smaller 2x over to your larger 3x on the right. In order to move the smaller 2x over to collect your variables, it's positive, you subtract 2x. If you subtract it on the left, do likewise on the right. 3x minus 2x is 1x. You still have plus 1 on the left, you still have equals 3. Plus 1 was on the right, you still have equals 3 on the left. Undo plus 1 by subtracting it on both sides, and x's value equals 2. Now you have a value for x, not an expression. Take that value for x, 2, and put it back into the other equation in place of x. So y equals 2 times our new value for x plus 3. Our new value we just found, x's value is 2. So y equals 2 times 2 is 4 plus 3, y equals 7. Written as an ordered pair, x comma y, 2 comma 7 is the solution. Don't do all of that work and then write it as 7, 2, because that will be an answer choice in a multiple choice test. Do all that work and just mix your x and y up at the end. 2 comma 7. That is the point where they will intersect. The same thing with number 3. Y equals 2x minus 10. Y equals 4x minus 8. Use the substitution method. Much easier to write them side by side. Y equals 2x minus 10. Y equals 4x minus 8. This is what y is equal to. 2 times x minus 10. So in place of y, plug it in. 2x minus 10 equals 4x minus 8. Bring your smaller 2x. Now we got x's on both sides. Bring your smaller 2x over to your larger 4x side by subtracting it. You subtract it there. Do it here. 4x minus 2x is 2x. You still have negative 8 on the right. You still have negative 10 on the left. Undo minus 8 by adding it to both sides. Negative 10 plus 8 is negative 2. You still have 2x on the right. Undo 2 times x by dividing it by 2 on both sides. And a negative divided by positive is a negative 1. X is negative 1. Now you got a value for x. Take that value, negative 1, and come substitute it back into the other one. So y equals 2 times x's value minus 10. We just found that x is negative 1. 2 times negative 1, y equals negative 2 minus 10. Y equals negative 12. You have an x and a y written as an ordered pair. X comma y, negative 1, negative 12. That is the solution. Negative 1, negative 12. Y equals x plus 6, y equals negative 2x minus 3. Again, substitution method. Write them next to each other. Plus 6, y equals negative 2x minus 3. Take this expression in place of y, plug it in place of y. X plus 6 equals negative 2x minus 3. Combine your, collect all of your variables on one side. Negative 2x is smaller than 1x. So add 2x to move it over because it says minus 2x. Add it here. 1x plus 2x is 3x plus 6 equals negative 3. Undo plus 6 by subtracting it on both sides. 3x equals negative 3 minus 6 is negative 9. Undo 3 times x by dividing by 3 on both sides. X equals a negative divided by a positive is a negative. 9 divided by 3 is 3. You have an x value, negative 3. Take that x value, bring it back into the other equation, and plug it in right there. Y equals negative 3 plus 6. Think of where you are on the number line. You begin on the left, you move 6 times to the right. You're going to pass 0 up, and you're going to stop on positive 3. Y equals 3. X comma y, negative 3, 3. Again, if you graph those equations, they would cross at negative 3, 3. That's what we're looking for. Number 5 says y equals 4x plus 6, y equals 2x. Again, substitution. Let's write them next to each other. 4x plus 6, y equals 2x. This is a smaller expression right here, so I'm going to choose to use this one and plug it in place of y. If you went the other way with it, it wouldn't make a big change. It'd be the same thing. 2x equals 4x plus 6. Since even though 4x is bigger than 2x, since we already have a 6 on the same side, I'm going to move the larger 4x over to the smaller 2x side. It's positive, so that means plus. Undo it by subtracting 4x. If you do it there, do it here. 2x minus 4x is negative 2x. Still have 6 on this side. Divide by negative 2. A positive divided by negative is a negative. 6 divided by 2 is 3. X is negative 3. Take that value, x is negative 3, put it in place of x. Y equals 2 times x is now negative 3. Y equals a positive times a negative is a negative. Opposite signs is 2 times 3 is negative 6. X comma y, negative 3, negative 6. Y is less than 4x minus 3. This is in mx plus b form. We can see it, mx plus b. B tells you where to begin. On your y-axis, begin at negative 3. M tells you where to move. Your slope tells you where to move. It says go up 4 and to the right 1. Remember, it's always a fraction. So up 4 and to the right 1. There's your second point. If it were an equation, we'd draw a straight line through it and we'd be done. It's not, though. It's an inequality. Remember, we have to make either a solid line or a dashed line. This is from last week. That does not say or equal to right there. That means instead of a solid line, we are going to make a dashed line through those 2 points. That's the first difference. The second difference is we're going to shade one side or the other. We're going to shade one side or the other. It does not pass through 0, 0. That is always a good thing for us. We're going to plug in and see if that is true or not. We're going to plug it right back into the original equation. 0, or the original inequality, is less than 4 times 0 minus 3. Anything times 0 we know is 0 minus 3. 0 is less than negative 3. This is not a true statement. 0 is not less than negative 3. So the side where 0's on is wrong. That means this is the side that needs to be shaded. 2x plus 4y is greater than or equal to 10. Before we can graph it, we have to get it into a form that we know how to graph. So move 2x over. 4y is greater than or equal to negative 2x plus 10. All we did was subtract 2x on that one. No reason to reverse the symbol. Divide by 4. Do it here and here. Y is greater than or equal to negative 1 over 2x. The number 2 goes into both of these, plus 5 over 2. No reason to reverse the symbol again, because we only divided by positive 4. We can graph this. It says y is greater than or equal to negative 1/2 x plus 5 over 2. 5 over 2 is the hardest part. mx plus b is what it says. But we have to take that 5 over 2 and make it into a mixed number to where we can graph it. This tells you where to begin 5 over 2. 5 over 2 is the same thing as 2.5. So your first point is going to go at 2.5, halfway between 2 and 3. Being precisely accurate is not as important in this as graphing the systems and finding the intersection. We're going to go down 1 and to the right 2. That's what our slope tells us to do. M tells you where to move. Down 1 to the right 2. Here's our second point right there. We have to determine, since this is an inequality, is it going to be a solid line or a dashed line? That says greater than or equal to. Or equal to, unlike number 6, tells us we're going to create a solid line through there. 6 was a dashed line, this one's solid. Does not pass through 0, 0. That's good. So we're going to plug 0, 0 into the original equation. Anything times 0 is going to be 0, plus anything times 0 again is going to be 0, is greater than or equal to 10. This is why we like to use 0, 0. It's easy to see that 0 is not greater than or equal to 10. That is not a true statement. So everything towards 0, 0 is wrong, which means everything the other way is correct. Number 8, y is greater than negative 2x plus 2. Y equals mx plus b. B tells you to begin at plus 2. M is negative 2. Remember, slopes are always fractions. Make them over 1 if they're integers. Negative 2 over 1 means go down 2 and to the right 1. There's the second point. Again, check to see if it's going to be a solid or a dashed line. This doesn't say or equal to. So it's going to be a dashed line. You don't count the line. So you make a dashed line if it is not or equal to. Second part you have to check. It doesn't pass through 0, 0. So we're plugging in. 0 is greater than anything times 0. Doesn't matter what it is. Negative 2 or what? 0. Plus 2. 0 is greater than 2. That's what we're checking to see if it's true or not. It is not true. So you're going to shade away from 0, 0, everything to this side. And then number 9 says n is less than negative 1. It doesn't specify to do it on a number line or a plane. But since we don't know which one is n representing x or y, we're just going to do it simply on the number line. N is less than negative 1. Show two numbers. Show 0 and show negative 1. Just show that it's on the left side. You know that's where negatives are. We're going to highlight that point, negative 1. This tells us, just like with the lines we were just doing, if it's going to be a colored in bubble or not. That doesn't say or equal to. That means don't count the bubble. That means don't shade it in. Leave it open. The variables first, it's pointing that direction. So you're going to shade that direction and is less than -1. Or all of your smaller numbers are that way is another way to look at it. Number 10 says write the following inequality in slope-intercept form. So we're just moving this, just like we did a little while ago. We're just moving it to make it say y equals mx plus b. It's not going to say equals because we're going to have ourselves an inequality sign. Okay, it's not going to say equals mx plus b. There'll be an inequality symbol right there. So, but we want to get y by itself. So we want to move this -9x over. It says minus 9x. You add 9x. If you add it there, you have to add it here. So what that gives you is -3y, positive 9x minus 33. You have to decide if you need to reverse the symbol or not. All we did was added 9 right there, or 9x. Remember, you only reverse the symbol when you multiply or divide by a negative number. So the symbol is going to stay just like that, less than or equal to. Last thing we have to do is we have to divide by -3 to get y by itself. If you divide that, you have to divide everything by -3. And what that's going to give us is y by itself. Positive 9 divided by -3 is -3x. Positive 33 divided by -3. Negative divided by negative is a positive 11. Unlike on the previous step where we didn't reverse it, though, this time we are dividing by a negative number. That's one of the things you have to do to reverse the symbol. It said less than or equal to. We're going to reverse it and make it say greater than or equal to. So y is greater than or equal to -3x plus 11.